Hello guys, today I am talking about the Hackathon project, which is GCP cost optimization. And this project is basically give an idea how can you optimize your cost onto the GCP. So this is our team and these are our members. Okay, problem statement and introduction. These are the content is covered in this documentation. You can see the architecture diagram. You can see the dashboard which we have developed through the data which is coming from the GCP, and the conclusion. The problem is statement: utilizing the GCP cloud cost optimization tool to optimize the server cost and resource performance. This is a big problem because if you have a large of the company and you have a lot of the data and residing onto your different of the servers, and most of the servers are underutilized, and this will affect your costing. And not only the servers, we have a lot of the other services, for example the database services and the lambda functions, and there are a lot of the functions, a lot of the resources that need to be utilized, fully utilized. So you need to hire a person for optimizing or downgrading or upgrading your servers. So instead of doing this, you can use this tool for your problem, and then you can save a lot of the money. So in the high level enterprise cloud setup, multiple server cloud application are used to provide the services to the end user. Due to this, a few resources are fully utilized. At the same time, a few are them are underutilized. So GCP cloud cost effective will analyze and resource and suggest to reduce the costs, and that will result in the cost reduction. So this is a basically architecture diagram. So what we have done, we have actually designed the dashboard, which is we have used the GCP Looker services, Looker Studio services. Basically this will give you a good outlook. You can design the dashboard, you can design the charts and data, something like that. So in this presentation we will show you how the data would like to be onto the dashboard. So we have a recommendation engine. The recommendation engine is basically give you our statistics or give you our decision making, that you can utilize the resources under which circumstances. So it will give you a complete recommendations. And then we have a storage. Once we have a scheduler that basically are called to the GCP functions. This GCP function is basically a lightweight call to the server and then get the data from GCP monitoring service. So let's suppose we have multiple machines and they have their time series data. So we have to get the data on a timely manner and then save into the storage, and this storage is being used by the dashboard to display the charts accordingly. And this is again background detail of the project. This tool will scan and billable of the component of the GCP cloud services. The initiative of the GUI containing the exceptional utilization will enable the end user to analyze their cost and resources. So we have designed the UI on a Looker Studio, which is a free tool, and then turn data into the informative and easy way to read and easy to share and fully customizable dashboard and report. So it's tell you the data story using the charts and graph. So we have used the GCP monitoring API, we have used Java Quarkus serverless architecture and GCP cloud functions. We have created a function in the Quarkus application, and Looker Studio will displaying the dashboards. So these are basically some snapshots. So you can see the running application. So this is basically let me show you. So this is our dashboard. So if you can see, this is the URL is available in the documentation. So this is a CPU utilization chart. So you can select the date, and these are some charts. These are basically instances average usage per date, and instances maximum usage per day. So you can select the date. For example, if I select the 1st October to 20 October, so it will give you responses that how many, which are the instances. For our GCP we have 3 instances, and they're all statistics for the particular date and time. You can see through the graph data. So, and you can, filter based on the criteria. So you can select the particular date. So we have, some data on 3 different basically instances, and these are some details regarding the per instances per date wise. So it is grouped by date wise, so you can see which dates, on which dates you can see the details. So if you have a, large of the date, so you can, see the small of the charts detail. So this is how you can see the data, and you can export every data to particular, CSV format. So you can play around with the data. And this is again the another of the chart, which is a percentage chart. So which servers are being utilized. So in this case, we have 3 servers and, 3 instances. So we have a limited usage, so it is showing on to the percentage wise. And similarly, instances per span. So in the each and every span, average, it is showing the average percentage. So average, they all are average percentage is below, 15, below 15. So this is how you can see your graphs. And this is our suggestion and recommendation box, that the instance 1, instance 2, instance 3 on particular day, the average, and other detail. And recommendation is that 60% billing will be safe, okay, because your utilization is 35%. So this is how it is suggesting that you can utilize, you can better, downgrade your servers according to the comment. So this is our application, and you can play around with this, and you can export the data. So which almost we have covered all the part. So if you have any question regarding um, in the presentation, so you can see that. So this is our basically conclusion, and this is our team member. And thank you. If you have any question, then you can ask. Thank you very much.